Welcome to the video on the analysis of protein content. In this experiment, we will be measuring the protein content in a number of dietary supplements. We will compare our results to what's on the label and we'll see if these products are worth the price. We will be using the Bradford assay, which is a quantitative assay that is based on the absorbance shift of the dye Kumasi Brilliant Blue, which exists in three forms. And when it binds to proteins, it changes color, and we can observe that color change using ultraviolet visible spectroscopy and quantify our protein content. In effort to quantify our protein, we are going to make a standard curve. Once we get the standard curve, we'll have the best fit line and we'll get the equation for the line, and then we can calculate our two unknown protein samples. For the standard curve, we will be using the protein standard bovine serum albumin, or BSA. The first pre-lab question asks you to determine the concentrations that you will use between 0.2 and 1.0 mg per milliliter of BSA to make your standard curve. Once these dilutions are planned out properly, we can head into the lab. Using the appropriate micropipetters, make up each standard solution of 1 ml total volume in a 2 ml Eppendorf tube using the BSA stock solution of 2 milligrams per milliliter. The first thing I would do is to grab all of your Eppendorf tubes and label them. So you have the 5 standard solutions of whichever concentrations you choose, and then you have 2 dietary supplements that you'll be testing as well. So you should have 7 tubes. This tray has 9 because we did all 4 of the dietary supplements. So using the micropipetter, I would add water to each of the 5 standard tubes first. If you add the water first, you can use the same pipette tip for all 5 samples because there's no BSA around yet, so your tip will not get contaminated. But remember, you will be adding a different amount to each tube as you've calculated in your table for standard preparation. So even though you're using the same tip or the same couple tips, you'll need your pipette set at a different amount each time. Once all the water is added, you can start adding the BSA. You can use the same tip for the BSA addition as well, as long as you do not touch the tip to the water. We don't want any dilution happening or contamination. One final note about making the standards, I always start from the least concentrated and move to the highest concentrated. That'll be throughout this experiment. Once both the BSA and the protein have been added to the tube, cap it and you're ready for the next step. Now let's prepare our dietary supplement samples. We will be making a 50-fold dilution for our dietary supplement samples. You're going to either use muscle milk or Ensure as the liquid samples. Using a micropipette, measure out 980 microliters of deionized water and put that into your sample tube. And then take 20 microliters of your actual dietary supplement, add that to the same tube. And then once you get that all put in, cap the tube and invert it a couple times for mixing. For the dry or powder samples, we are going to take 10 to 20 milligrams of our sample and dissolve it into 1 milliliter of deionized water and mix well. Once all 7 of your samples are made, we're ready to do the Bradford assay. Get your 8 clean, empty test tubes labeled and ready. And to each tube, add 100 microliters of your sample. Start with the lowest concentration first. In the 8th test tube, you will make a blank, which is adding 100 microliters of deionized water. You can continue to use the same pipette tip at this stage as long as you go from low concentration to high concentration. Once your samples are added to the appropriate test tubes, add 5 milliliters of the diluted dye reagent to each test tube and mix the contents using a glass stirring rod. Incubate at room temperature for at least 5 minutes, but no more than 1 hour. Now, from the box of cuvettes, you'll grab a cuvette and you'll see that there's 2 sides, a clear side and a frosted side. Be sure to position the cuvette properly in the instrument. Make sure that the instrument is set to 595 nanometers. Then press enter. Now starting with your blank sample, so it's the Bradford reagent plus 100 microliters of distilled water, rinse out the cuvette once and then fill the cuvette. Make sure the clear side of the cuvette is facing towards you so that the laser can go through that. So the clear side is facing us there. Put it in the instrument and then hit the button, measure the blank. Once the instrument is zeroed out, you are all set to start reading your actual protein samples. Take the cuvette, rinse it out with distilled water, grab your second smallest concentration. Remember, we'll start with the smallest concentration. Grab the second sample, or actually the first sample with protein in it. Clean out the cuvette once, put the cuvette into the instrument, again, clear side facing you, and then the measurement will just appear on the screen. You don't have to hit anything. An absorbance of 0.307 is our answer for the smallest concentration in this sample. Measure all of the standards and then the 2 compounds for your dietary supplements. Record those absorbances from the instrument. Now you're going to make a standard curve using the BSA samples, and then you're going to use the best fit line equation to back calculate the concentration of your 2 dietary supplements. Please don't forget that you did a 50-fold dilution when you made up the dietary supplement sample, so don't forget that in your calculations. And now, safety with Jane.
Unlike displayed in the video, it will be important to wear gloves for this experiment. The Bradford dye reagent will turn your hands temporarily blue, so unless you are hoping to look like a Smurf, gloves are recommended. The dye will also stain clothing. All pipette tips and centrifuge tubes can be discarded in the regular waste container. Easy peasy.
There you have it, the analysis of protein content in dietary supplements. Okay, good luck.